Continuing on from our previous video, let's take a look at one final example. Working with economics, let's optimize. Let's start by reading the question. A bus company will charter a bus that holds 50 people to groups of 35 or more. If a group contains exactly 35 people, then each person will pay $60. In large groups, everyone's fare is reduced by $1 for each next person in excess of 35. Determine the size of the group for which the bus company's revenue will be the greatest. So let's just start by highlighting some important pieces of information here. We know the bus holds a maximum of 50 people, so that's going to be a constraint. They only hire it to people, groups of 35 or more. Each person pays $60. In large groups, everyone's fare is reduced by $1 for each person above 35. Determine the size. So we're revenue, so R of X, will be the greatest. So we're going to maximize it. I'm going to start by just making a little table of values so we can understand what's going on here. So I'm going to have number of people on the bus, and we're going to have the price per person. So we've been given information in the question already. We know that if there are 35 people, that each person pays $60, and the price decreases as we increase the number of people. So if there are 36 people, the price is $59. If there are 37 people, the price is $58, and so on. And we can express that in a general formula where we have number of people is X, and the price per person is $60 minus X minus 35. So that represents the increase in number of people from here. Let's actually write that down here as well. And we'll say X minus 35. This represents the number of people in excess or above 35. So how many more people than the original 35 do we have? All right, let's set up our problem. Let's define our variable first. So we're going to say let X represent the number of people on the bus. So what are our constraints? Well, we know the minimum number of people is 35. They won't allow less than 35 people to rent a bus of that size. X, and our maximum number is 50 because that's the most people that we can fit on the bus. And we need to know our revenue function. We need R of X. And what do I know about revenue? Well, thinking back to our previous videos, let's scroll up and see what we know about revenue. Oh, look, here's our revenue function. Revenue is going to be price per person, or our demand function, times X. So it's going to be revenue is P of X times X. And do I know some kind of formula? Do I know how to calculate the price per person? Yes, I do. I found that over here already. Price per person was 60 times X minus 35. So let's put that in, and then X is just X. So I'm actually going to reverse the order right away to make my life a little easier. So X is going to come first. So I'm crisscrossing here. I'll use some arrows to indicate that, because multiplication is commutative. That means the order doesn't matter. And our demand function is 60 times X minus 35. All right, let's tidy that up a little bit. So we're going to have X times 60X minus Actually, we have a mistake here because we're going to get some huge numbers here. So once again, I've made an error. I'm going to leave this in the video, though, to show you, because I noticed I'm going to have to like multiply 60 times 35. We're getting numbers that are way too big here. I made a mistake in my price per person here. It's 60 minus in excess, because it's how many more people are joining, and the price goes down by $1 for each of them. All right. Conceptually, though, we're on the right track. We just had the wrong demand function. Now that that's fixed, let's keep going. So 60 minus x minus 35. Let's tidy this up. So 60 minus, or 60 plus 35 is going to be 95 minus x. And we can multiply through, and let's get negative x squared plus 95x. And so I have my revenue function. Looks good. And so what? Now that I have that revenue function, what do I need to do with it? Well, I need to optimize it. I need to figure out what is the value that will grant, the value of x that will grant me the largest revenue. And so I'm going to need to set my function equal to 0 and then test to determine if it's a maximum or a minimum. So I'm going to find my derivative. And I'll just write a note. We're going to set our function, derivative function equal to 0. So the derivative is going to be r prime x is equal to negative 2x plus 95. I'm going to set that function equal to 0. So negative 2x plus 95 equals 0. And I'm not going to show all my work. You guys know how to rearrange and solve questions like this. X is going to be equal to 47.5. So if we're thinking about our graph, this is our critical point. And there's a problem here. What does x represent? X doesn't represent like a price. X represents a number of people. We need an integer. So is it going to represent 47 people or 48? I'm actually not going to answer that question right now, but we're going to keep that in mind as we start testing our values. So what do we know when we test our values? We're looking for the maximum possible revenue. So I'm going to test my endpoints and my critical point or points. So as we test, so we're going to evaluate our function, our original function for my endpoints, so 35, and my middle critical points. So I'm going to test 47 and 48. And then my other endpoint from here is 50. So I'm testing minimum number of people, maximum number of people. So those are the endpoints of my interval. And then I'm also testing my critical points here. And so I'm just plugging them into my revenue function, which is right here. And once again, I'm not going to show my work as I evaluate because you are all capable of doing that. And instead, I'm just going to share the results. So let's evaluate our function. So when we are evaluating for 35, our revenue in dollars is going to be $2,100. For 47 people, $2,256. For 48 people, also $2,256. So it doesn't actually matter. Either value will maximize our profit. Basically, we can probably think of it like this, that we have a curve, revenue as a function of x, and like 47 is probably right here. 48 is right here. And I say probably because I haven't looked at the graph. And in order to get the actual maximum, I need 47.5 people, and that's not possible. So that's why these are tying for maximum revenue. They're like symmetrical about the line of symmetry or whatever. And I say probably just because I haven't actually graphed it. I'm just using what I already know to describe about how these situations work to describe what's happening. Finally, let's evaluate our function for 50 people, and it's 2250. So which values are going to maximize? It's going to be 47 or 48, and they are tied for max. All right, so we're actually done our calculation. So just like we've done before, we defined everything, we set our constraints, we defined our variable, we figured out which function we needed, we found the derivative, and we set it equal to 0 in order to identify the local extrema. We found the critical point. And I guess we didn't actually prove that it was a max. I didn't do my interval test. How do I know that it wasn't a minimum? We can kind of already see from the numbers. But I guess we did kind of prove that, because when I tested 47 and 48, instead of my actual value of 47.5, I was testing on either side. Just to confirm, let's actually evaluate our function for 47.5 and see what we get. So if I evaluate for 47.5, yeah, I get a value of 2256.25. 2256.25, as opposed to my other value of 2256. So we have confirmed, we've kind of done the test along the way to prove that our point here is indeed a maximum. I just wanted to be a little more explicit about the fact that we should double check these things. All right, we are done our calculation. Let's just state our final answer. So therefore, the company has or maximizes greatest revenue for a group of 47 people, in which case the ticket price is $48 per ticket, or 48 people at $47 per ticket. And once again, I didn't show the per ticket calculation, but all you got to do is take your X value, plug it back into our demand function, and then you can find that value. It's not strictly necessary, but for the sake of having a nice complete answer, I have included that here. And this is our last question, and this is the end of this video. So there's nothing else to say. We are now experts at optimization and working with economics.